Welcome everyone to this very important videos of basic data analysis. Requesting all the viewers to revisit this video and time and again will be a little bit shorter, but at the same time would be taking a little bit of more of an effort from your end to understand the basics of data analysis. In most social researches, data analysis involves three major steps done roughly as in cleaning the organizational data. That's what we prepare the data for. Describing the data as in descriptive statistics, testing hypotheses and the models, inferential statistics, as the case might be. Data preparations, let's say, involves checking or logging the data in, checking the data for inaccuracy or accuracy perhaps, entering the data into computers, transforming the data and developing the documenting a database structure that integrates the various measures. So that is what data preparation is all about. It checking, sequencing, prioritizing, and probably segmenting the data to check for the accuracy, entering them in the computer. Descriptive statistic is used to describe the basic features of the data in the study. They provide with simple summaries about the simple and measures. Together with simple graphic analysis, they form the basis of virtually every quantitative analysis of data. With descriptive statistics, you are simply describing as is what is happening, what the data is actually letting you know. Inferential statistics, investigating questions, model, hypothesis. In many cases, the conclusion for inferential statistics extends beyond the immediate data alone. For instance, we use inferential statistics to try out infer from simple data when the population thinks so, or we use an inferential statistic to make judgment of the probability that an observed differences between the group is dependable. One that might have happened by chance. In this study, types of statistics, univariate statistical analysis, test of hypothesis, involving only one variable, test of statistical significance thereby. So bivariate statistical analysis, test of hypothesis involving two variables. Multivariate statistical analysis involving three or more variables or sets of variables. So we have univariate, we have bivariate, we have multiple variates statistical analysis. Let me introduce the key terms of statistics. One is hypothesis, and the other one, the opposite of it, is null hypothesis. Unproven proposition, a supposition. Remember, it's a supposition that tentatively explains certain facts or phenomena and assumptions about the nature of the world, perhaps. And you can name everything. If it rains, probably more than 60% of the people would either carry a raincoat or an umbrella if it rains. That's an hypothesis that we go around it. Null hypothesis is just the opposite of it. No differences in sample and population, irrespective whether it rains or not. Only a handful of people would be carrying umbrella or raincoats, perhaps. So that's what the null hypothesis is all about. It just the other way, the 360-degree. It's not 360, but diagrammatically opposite point of view, as in 180-degree. Alternative hypothesis statement that indicates the opposite or the null hypothesis. Let me give you hypothesis. So, what are we looking? We are talking about unproven propositions. We're talking about assumptions in the null in the nature. So there is a null hypothesis where there is no difference in the sample and population. They are identical to each. Alternative hypothesis indicate the opposites of the null hypothesis. Let me give you to the choosing of the correct statistical technique. Require following consideration. Let's say the type of questions to be answered, numbers of variables involved, level of scales to be measured. We are talking about types of question to be answered. Is it a lengthy question, subjective question? Is it a prefixed answer that has been given? Is it to be rated scale? Is it to be ranked around? What are you looking? Is it multiple responses are acceptable or not, or is it unique only one accept answer or responses is taken down? So you need to understand the number of variables that you are getting involved into it, number of variables to prove your thesis or prove your hypothesis thereby. That's the level. Then we design the tools to measure it, the scale of measuring it. Univariate analysis involves the examination of just cases of one variable at a time. Rest all the variables might remain constant. There are three major characteristics of single variable that we tend to look at: the distribution, the central tendency, and the dispersion over the data. In most situations, we would describe all the three of these characteristics for each of the variable in a study. Perhaps This distribution, the distribution is a summary of frequency. If you look into it, this is what we are looking at, the summary of frequency that is occupying around here. The range of values for the variable. The simplest distribution would list every value of variable and the number of percent that we have in each value. So that's under 35 would be less than 9%. Between 36 to 50, the category, it might be ages, it might be marks, it can be anything, it might be weight also. No, whatever you look into it, if you look into it, you will see a more or less a bell curve coming around, which is somewhere down the corner is skewing 9% to 6%. In between is the 45%, the 46 to the 55 category bracket. So that's the bell curve that we are looking out here. This is the data, and this is the pictorial representation of this data out here. So distribution may also display the use of percentage. For example, you can use percentage to describe the percentage of people of different income level, of different age ranges, of different range of standardized test score, as I just said it to you in the previous slide. Central tendency is the tendency of distribution in is an estimate of center of distribution of values. There are three major types of estimates of central tendency. What are they? Where are they? We are talking about mean, median, mode. So that is what central tendency is all about it. No, what are we looking? Let's say we have our data sets of 15, 20, 21, 20, 36, 15, 25, and 15. Something called random. The sum of all these 8 values is 167. So what is the average mean? 167 divided by 8 would give me somewhere around 20.875. So if you order the 8 scores above, we would get it 15, 15, 15, 20, 20, 20, 21, 25, 36. This 8 score, the score number 4 and 5th, 20 and 20, represent the halfway point. Since both of the scores are 20, the median is 20. If the two middle score have a different value, we would have to interpolate to determine the median thereby. That is what we need to understand. So if you have got an idea of how to find out the median part, to determine the mode, you might again order the scores as shown above, then count each one of them. The most frequent occurring of the values is what we are talking in our example. The value 15 occurs 3 times and is the mode value. This is what we are talking about. The value 15 occurs 3 times, so that becomes the mode. The medium is the central nominated when we are doing it in ascending fashion. Dispersion refers to the spread of values around the central tendency. There are two common measures of dispersion: the range of standard deviation. Something which you need to understand. The range is simply the highest value minus the lowest range. For example, the distribution that high value is 36 and the low is 15. Show the range. 36 minus 15 would be 21. So this is my range. From the minimum value to the maximum value is my range altogether. And that's how the data has been dispersed over altogether. The standard deviation is more accurate, which details the estimate of dispersion because of the outlier can get aggregately or exaggerated the range, as was true in this example when a single outlier was having a value of 36, which stands apart from the rest of the value. The standard deviation shows the relation between the set of the scores and the means of the sample thereby. So we have a simple variations to go across with it. Now, what is the standard deviation? This is my average mean that goes around here. So 15, the lowest denoted data is 15 minus the average mean is 5. That's the standard deviation that goes around it. 21 by the average plus 1.25, sorry, plus 0.125. The maximum value is 36 minus 20 is 15.125. Then comes 15 minus 20, or the highest value will be 25 minus 20 is plus 45. Now we have these value 15, 20, 21, 20, 36, 15, 25, 15. Everything has a standard deviation. What are we looking into it? We are trying to come up with standard deviation, which is summation of the maximum to the minimum value, the sum score into number of data 8 minus 1. So x is the score which comes around it, the mean and the average. Remember, x is e scores and x hash. This is what the mean or the average is all about it. What is the mean? Is 20.87. summation means sum across the values. So if we have to have the numbers, there are total n as equal to 8 data. The mean is 20.8750. Median is 20 because it was been ranked 4th and 5th in order. The mode is 15 because 15 is represented thrice in the data. Standard deviation is 7.070799. As a difference, if you will understood with this formula, variance is 50.125 and the range is 21. 15 minus 36, or should I say 36 minus 15, the range is what all about it. This is what is been meant out here. So bivariate analysis, the correlation is one of the most common, most useful statistic. The correlation is a single number that describes the degree of relationship between two variables. Let's assume that we want to look at a relationship between two variables, height in inches and self-esteem the other way around. Let me give a person, there might be 20%, 1, 2, 3, 4, 5, 6, 7, 8. I'm not giving them the name, but perhaps the number, so as it becomes easy for each one of us to recall. Their heights have been noted as 68, 71, 62, 75. This is what we are looking in terms of the height, and it varies altogether, right? The self-esteem is 4.1, 4.6, 3.8. So is there any relationship between the height of a person and the self-esteem? Height is measured in inches. Remember, self-esteem is measured on the average scale of 10 to 1. On average of 10, 1 to 5 being the rating, where higher esteem scores means higher self-esteem. Now, this is what we are going around it, and we have to represent it in the pictorial representation. This will the way it will be represented: the variable, the mean, the standard deviation, the variation, the sum, the minimum, the maximum. If you look into it, we'll get the ranges all together, the heights, mean height. What is my standard deviation? The variance is the sum, summation altogether of all the heights, the minimum being or the maximum being what we are looking into, the range is 75 minus 58, and things would fall into places. What is the self-esteem? And this is how data has been analyzed. I am trying to give you an example of easy, simple data analysis that comes around it. With this, I come to an end of this recording. Thank you for watching this video.